So let's do a couple problems with the extended power rule, which is what you use when you have a function in the form x to a power. Sometimes they're disguised as, for example, square roots or fractions. But let's look at the first one. Remember that the square root of x is actually x to the 1/2. And once we have this, we can use the power rule, bring the 1/2 down, and then you subtract 1 from the exponent, so the exponent becomes negative 1/2. Remember that x to the negative 1/2 means 1 over x to 1/2. X to 1/2 being square root of x. So 1 over x to 1/2 would be 1 over root x. And so the derivative of root x is 1 over 2 root x. It's actually a good one to memorize. Here, we actually have x in the denominator, so this is x to the -1, minus for the reciprocal of x, and 1 for the first power. So you bring the 1 down, that's -1, x, subtract 1 from the power, from the exponent, you get -2. And x to the -2 means 1 over x squared. So this is really -1 over x squared. If I have 1 over x squared to begin with, this is actually x to the -2. Since you have x squared in the denominator, bring the -2 down. We reduce the exponent by 1, so you have -3 in the exponent. So this is -2 over x cubed. Let's do the last two. First of all, cube root. Remember that you can write the cube root as an exponent by doing x to the 1/3. And that would give you 1/3 x to the -2/3. And so just a quick reminder, when you have a rational exponent, this means power and this means root. So this 3 means third root. And when you have a 2 as a power, it means take x to the second power and then you take the third root. So this is 1/3 times 1 over x to the second power and then the third root, or 1 over 3 cube root of x squared. Alternatively, you can write x to the 2/3. And finally, this one, we want to write it out as an exponent. Remember that you have a third power, so the numerator of the exponent is 3, and then you have a second root, a square root. So this is x to the 3/2. So this is 3/2, x to the 3/2 minus 1, or 1/2. And so this is 3/2 times the square root of x, since x to the 1/2 is root x. So whenever you see a single x with roots or power and or powers on it, such as these, or if you have 1 over one of these things, you can just rewrite the function as a power function, as x to a power, and then take the derivative with the power rule. And always remember that when you have a rational power, when you have a rational exponent, the numerator means take x to this power, and the denominator means take this root of x, and negative sign once again means reciprocal.